Okay, so this is the Engineering Economics, part 2 naman. Here we're gonna be discussing yung different parts different variations ng annuity naman. So first up is in deferred annuity. So the only difference on ng annuity na pinag-uusapan natin before is that it's still equal payments spread over equal intervals of time, but you're deferring your first payment, annuity na yan. So just reading the definitions dito, deferred annuity is where the first payment is made several periods after the beginning ng annuity. Examples ng annuity na to, tulad ng retirement funds, pensions, life insurance policies, maturity, and similar financial products. So just to derive yung equations natin in deferred annuity, we won't be introducing a new formula. We'll still be using yung present worth annuity formula na yun, like I told you earlier. And the only difference is we're accounting yung difference ng we are accounting yung amount of period the first annuity payment is deferred. So this one is still yung present worth annuity mo. As you can see dito, this is where ito yung last part at which ito yung basically yung sa annuity lang natin. It looks like yung ordinary annuity. And then here is in deferred period niya. Kay Santa Maria, nirefer niya dito as M or M plus N basically, so that it will do. Pagdating dito, we have to account na pagdating dito, from this perspective, this is like its future worth. And if we're gonna get it, since we can get yung value natin dito by returning yung present worth value using yung annuity formula at to this point, from this perspective, from 0 to this whatever period this is, this looks like yung future value niya. So we can definitely get ito yung present worth nito using yung formula na to before, if you recall. Maalala nyo pa to? Okay. This one is this, yung whatever yung value na makuha mo dyan. Hence why we represent yung formula to such as this. So we account yung amount of years or amount of periods deferred siya, and all we have to do is return it back to its present value dito. Here's another showcase na equation. Not sure kung pinagkaiba nito na doble yata. And then there's this one, although hindi ko siya ginagamit personally. Let's try a sample problem dito. Here we have 10,000 pesos deposited each year for 9 years. How much annuity can a person get annually from a bank every year for 8 years starting 1 year after the 9 years deposited? So, ibig sabihin lang nito, so yung cost of money dito, again, yung cost of money dito is yung interest rate natin or yung cost of borrowing. So, pagdating dito, just checking lang yung mic. So, pagdating dito, 10,000 pesos nag-deposit for 9 years. So, meaning, for 9 years, at the end of the year, wala naman saan sinabi, unless specified. So, may 10K dito for 9 years. And then, you will person daw can get an annuity for 8 years after the starting, after the 9th deposit is made. So meaning makakuha siya ng certain annuity dito for 8 years. So 8 plus 9, that will be 17 total periods dito. We don't know that. So the question is, how much daw? Meron tayo interest rate na 14%. And quite frankly, we can solve this not together. So there are actually 2 ways for you to solve this. Let me just remove all my ink dito. Yeah, so 10,000. Yan. Yan yung naharap natin. We can solve it by bringing it all back dito sa present. Dito. So we get yung present worth annuity neto. And then factor in yung present worth factor neto. Okay, and then that includes also this guy. Lagay natin yung annuity na to and kunin natin yung basically yung present worth annuity na to. Wait, sorry, mali pala to. Present worth annuity. So pag sinulat ko lang yung equation na to in this manner, it's still the same formula pa rin naman, So sinashortcut ko lang. ito yung annuity P over A, percentage, and then yung period. In this particular case, this is gonna be 9. Ito naman kung i-translate ko to, that will be annuity. Since hindi natin alam yan, so it's gonna be P over A. In this particular case, 14%. And this one is 8 years. Yeah. Okay. So, we can do definitely then i-multiply na lang natin to with yung present worth factor nito. So, all we have to do is this one. This is yung 10,000. 1 minus 1 plus equals. Since ito, pare-pareha sila ng total present worth factor, if itong entire line na to should equal to whatever yung present factor na to. So, equated to x plus 1 minus 1 plus 8 negative 8 divided by 8. And then makukuha natin yung x, which is yung present worth factor, 1 plus I, negative 9. Kasi 9 years in nandito. So, this should match. Basically, should be equal. That'll be 34,675. Another way of solving it is you can still get yung present worth yung present worth annuity na to. So whatever yung P at 10 ito, that's gonna be A1 minus 1.14 negative 8 divided by 0.14. However, you can do it reverse naman. You can get yung future worth naman ng 10,000 at the future worth annuity. Okay. Up to this point pala. Wait lang. Sorry, may mali ako. So, ito yung starting. Ito yung 0 niya. Ito yung 1, 2, 3, 4, 5, 6, 7, 8. Basically. Okay, so we can get, ito yung border natin dito. Diyan nagsimula. So you can get yung present worth niya hanggang dito. Yan. Present worth annuity. So P at 9. P over A, 14%. This is gonna be 8. And here naman, you can get yung future worth annuity nito up to this point. So meron ka ng 10,000 dito. So that's F. That's gonna be A. F over A, 14%, and that's gonna be total of 9 years. So if we got a using equation, and it should look something like this. And since we're just getting it up to this point lang, no need to factor yung present worth factor na to. So we're meeting we're meeting sa 9th period lang naman. And we will get the same answer of 34,675. So yung kanina, so yung kanina, we converted everything back to present. So yung present worth factor nun. Let me just correct lang yung arrow ko lang dito. So everything should be here. Ito yung border basically. So kinuha natin yung present worth annuity nito. And this is 8, and then we multiplied it. So whatever yung value natin makuha dito, we multiplied it to its present worth factor. So definitely we just use this one. So 14%. And then this is 9. At the same time, kinuha natin yung annuity na to, which is P over A. So P over A, 14%, 9 years. So itong dineposit natin for 9 years on that generates this annuity. So the present worth ng either annuity should be equal to yung total present worth dito. Okay? Hence, inequate natin sila. Let's try another problem. This time, we have on the day his grandson, hindi ko alam bakit may on the day his grandson was born, a man deposited to a trust company a sufficient amount of money so that the boy could receive 5 annual payments of 10,000 pesos each for his college tuition fees, starting with his 18th birthday. Interest at the rate of 12% per annum was to be paid on all amounts on deposits. There was also a provision that the grandson could elect to withdraw no annual payments and instead receive a single lump sum amount on his 25th birthday. And ito yung pinili ng grandson niya. So ang tanong, how much did the boy receive as a single payment? And B, how much did the grandfather deposit? Okay. Reading the problem, we know that we need to find what is the total accumulated amount na yun, and then ano yung initial deposit. So how do we decipher this? Let's start by drawing yung cash flow diagram muna. Since the boy elected not to receive yung 10,000 pesos each for 5 years at his 18th birthday hanggang 22 years old, instead, he opted na i-receive lahat yon in his 25th birthday. Ito siya. And ito yung 10,000 pesos starting 18th birthday. And makaka-receive siya ng 10,000 pesos until 22 years old siya. However, that did not happen. So ito yan. So let's redraw again yung cash flow. So instead, to solve yung A, so essentially, meron 10,000 dapat na ma-receive siya dapat, pero he opt na i-forgo yun. So instead, we need to find yung future worth neto. So recall, we can get definitely yung future worth annuity na yun using yung future worth annuity formula, which is this one. Okay? But bear in mind, we have to factor in yung gap dito. There's a gap here. 22, 23, 24. So that's gonna be 1, 2, 3-year gap dito going sa future 25th. Okay, after all, we're just forecasting lang naman yung maging accumulated niya. So in this case, we just have to include that in, plug and play. The 10,000 pesos, 1 plus 0.12 raised to 5. Say 5 siya. Kasi this is 1, 2, 3. Sorry, mali yung count ko. Dapat 1, 2, 3, 4, 5. Ganun yung count. 0, 1, 2, 3, 4, 5. There we go. Kaya 5 to. This is 0.12 and then 1 plus 0.12 raised to 3. Bakit? Kasi it's 3 years into the 25th birthday from the 22nd year. So that's gonna be 1, 2, 3. Okay? So we will get the amount to 89,252.93. Now, to get naman yung how much did the grandfather deposit, all we have to do is similar to what we did earlier, is like any deferred annuity problem. We just have to get your present worth value and multiply it by its present worth factor dito. So once na makuha mo yung value dito, P at 17, you multiply this. This looks like yung future worth neto. So yung P ng 17 multiplied by 1 plus I raised to whatever yung gap na to, which is negative 17 years. Okay? So recall we have that formula. Okay? And all we have to do na lang and then substituting yung formula, yung mga known values natin using yung formula. There we go. So 17 kasi single payment lang naman siya. So we have no annuity here. So naglagay siya ng deposited a significant amount, a sufficient amount of money. So one deposit lang siya. So and then from there we will get around 5,250.15. But there's also another way to solve yung present worth ni grandpa. We can use yung total future worth natin from here. It's already know future worth. And then all we have to do is just use this formula. And gagamitin natin yung period dito na 25. Single payment lang naman yan eh. Okay? We could use that formula and we would arrive at the same equation but in 5,250.15. As you can see, I'm not introducing, the only formula I introduced dito is yung annuity formula, which we could use yung present worth and your future worth. And bear in mind, ang nadagdag lang naman dito is whether you're moving it forward or you're moving it backward. Further. especially for deferred annuity naman. Okay, and we're still using yung pinaka-basic present worth and future worth formula natin. Maliban na lang dun sa annuity formula natin. Okay? The next type of annuity is called Annuity Due, and the difference, it's still annuity. As you can see here, this is the usual formula pa rin. Pero the only thing we can consider dito is that the annuity, the first payment is already paid on the first period kaagad. So ito yung 0, 1, 2, 3, 4. It's being paid kaagad. Hence yung formula niya, so ito yun. This one yun. Usual P, and then we just add yung first payment sa first period. First annuity payment sa first period. So, ito yung derivation niya. As you can see, that's it. And then we just add yung A. Okay? And then we could decipher, if we could, derive a formula further, we could also use this one. Okay. Or you could also use this one. P is equals to A1 plus 1 minus 1 plus I raised to negative n divided by I. That's another formula that you could use. It's pretty much the same. Ito kasi may n plus m yan, n minus 1 yan. Yung n minus 1 na dito yan, n minus 1, n total n. Yeah, there we go. Okay, let's try it. So here we have two sample problems. So a man bought an equipment costing 60,000 payable at 12 quarterly payments, each installment payable at the beginning of each period. The rate of interest is 24% compounded quarterly. What is the amount of each payment? So we draw yung cash flow natin muna. We know na meron tayong biniling 60,000 dito. And meron tayong 12 quarterly payments dito. What is the amount of each payment? Yun ang hinahanap natin. Okay? First things first, okay, we need to convert the rate of interest into interest rate per quarter. So, ang gagawin lang, ang formula lang naman natin is nominal interest rate divided by compounding period. So, in this case, quarterly, so that should be 4. Ito yung formula for annuity due. So, it's just a combination lang ng yung present worth annuity, then on plus side, just another formula dyan. So, that's our interest rate per quarter, 0.06. And applying it, and we would get the annuity at 6,751.53. Sa libro ni Santa Maria, nakalagay dyan 0.24 divided by 3. And if that's your answer, that's that. And if nalito po kayo doon, that's fine. Pinag-diskusyon na namin sa klase yan. Like 4 times. Next up is here. A certain property is being sold, and the owner receives 2 bids. The bidder offered to pay 400,000 each year for 5 years. Each payment to be made at the beginning of each year. Another bidder offered to pay 240K for first year, 360K for second year, and 540K for third year. For the next 3 years. All payments will be made at the beginning of each year. If the money is worth 20% compounded annually, which bid should the owner property accept? Okay. So, interestingly, I received a question dito kung pwede kong gawin a future worth annuity naman to. Technically, pwede. Okay? Kasi either way, kung sino pa rin yung may pinakamalaking future value neto, definitely is the best winner. But for most of the time, these are forecasted values kasi. Hence, most of the time, we are doing yung present worth annuity because we are estimating yung value now. We're interested on the value the present time. Hence, the present worth, the usage, yung gasgas na usage natin ng present worth annuity. Okay? So first things first, we draw your cash flow. So bid 1 should look something like this. Paid at the beginning of each year. So so 400K, 400K, 400K. So what's 1, 2, 3, 4, 5 kagad. And cost of money 20%. And then yung bid number 2 should look something like this. So pag sinabing first year mo ilalagay dito. It's paid in the beginning of the year. So 240K, 360K, then 540K for that 3 years, And para mas spot po kung annuity due problem siya, if it's always paid at the beginning of the year, paid at the beginning at the period, so on and so forth. So how do we go about this? So we solve muna yung present value ng each. Let's try muna yung bid 1. So ito yung sa bid 1. All we have, ito yung ginamit kong formula naman this time. N minus 1. So in this particular case, magiging 4 siya. So magiging 1, 2, 3, 4. There we go. And we will get a present value of 1,435,493.83. Next up is for present value 2. You can use other formulas rin ng Annuity Due equations natin, but it'll still yield the same pa rin naman. For P2, ganun rin. But the only difference is 240K dito. That's our present value. That's our now. At 360K, this is yung value in 1 year's time. So we have to multiply it by present worth factor. 1.2 raised to negative 1. And then yung 540 natin dito doesn't look like an Annuity Due problem. So I just treated it like a deferred annuity problem where I just simply use this one. And meron lang siyang gap na 3 years. So parang ganito. So I returned yung present value niya at P1. So yun yung annuity, P over A, which is 20%. And then this is 1, 2, 3. And kaya siya negative 3. And then meron pang gap dito na 1 plus I raised to negative 1. So i-multiply ko na lang yan doon. Kaya negative 1. And the value I got dito is 1,487,116.67 pesos. So since P2 here is greater than P1, I accept yung bid 2. Okay. Well, the other kind of annuity is called perpetuity. It's an annuity which payments continues and indefinitely. You can see, ito yung classic formula natin, pero hindi define yung period niya since it's infinity. And ito lang naman yung formula ng annuity. Types of perpetuity. Ito lang naman yung formula ng perpetuity. And types of perpetuity to like stocks, bonds, royalties, real estate, and capitalized costs, especially pagdating sa mga maintenance ng equipments. Yearly maintenance, rent, operations costs, so on and so forth. As for capitalized costs, ito yung cost ng any property is the sum of the first cost, the present worth of all costs, replacement, operations, and maintenance for a longer duration of perpetuity. That's pretty much it. Sige. Let's try solving a problem dito ng perpetuity. Here we have a type of problem where we're being asked how much money to be invested today so that we can provide this scholarship. So 15% interest. You can provide the following on scholarship: 30,000 at the end of each year for 6 years, 40,000 for the next 6 years, and then 50,000 thereafter. So thereafter, that means perpetuity to 50K na to. So ito di ko lang na-animate, pero the cash flow diagram would look something like this. So we're looking yung initial deposit now. So here's the perpetuity. Okay, let me just do everything dito. So as you can see dito, we need to know yung money now, yung present worth now. So we need to use yung present worth annuity equation natin, except for this particular annuity, perpetuity. So that's 50K divided by 0.15. However, dito, we need to factor in yung present worth factor niya. Yung value na nakuha niyo dito. So yung P12, you have to put it back into the P at 0. Okay? That same goes for here. This is just, titignan natin to, this is just deferred annuity lang. So we use yung deferred annuity equation natin dito, which is pretty much yung multiplying yung present worth factor. And this one here, it looks like a ordinary annuity problem lang dito. So this should be no-brainer dito. So applying yung equations na yun, here, recall them. Here's the solution. Yeah, it looks something like this one. And then you will get 241,282.32 pesos if you apply and solve your equation ito. Here's another sample for perpetuity, this time with capitalized costs. I'm just gonna show you yung problems. So we need, you have a first cost dito, which is initial investment of 1.5 million, which is this one. And then you have a annual maintenance cost of 150K indefinitely at 15%. So the capitalist cost is basically first cost plus the present worth of perpetual operations and maintenance and plus perpetual replacement. So, how does that look like? Ito lang naman yung tsura niya. So, yung perpetuity to, so that's just yung annuity, that's 150k divided by 0.15. That's pretty much it. And if you're gonna rearrange yung cash flow diagram niya, ito dapat yung tsura niya. Here's another perpetuity problem. Here, instead of yung period niya every 10 years, every year, every month, here we have every 15 years, every 10 years, so to speak. So in this particular case, we have yung new engine installed by a textile plant at the cost of 300,000 pesos and projected to have a useful life of 15 years bago siya i-replace it. So another 15 years to have another new engine and then another 50 years, so on and so forth. Ngayon to, at the end of its useful life, meron siyang salvage value of 30,000 determined in the capitalized cost if the value of money is 18%. Pag ganito, ito yung cash flow diagram niya. Draw it muna. Every 15 years, you have a salvage value of 30k. So, meaning we're talking of periods of years na dito, no? So, I'll just have to factor in one interest rate equation lang dito. Where you have to factor in yung every 15 years lang dito, or every k amount of years. So that is 1 plus yung percentage, yung interest rate per year, which is 18%, raised to k, in this case, 15 is 15 minus 1. Okay? And you just have to apply lang yung equations natin. So capitalized cost plus first cost neto, which is what? Ito yung first cost, 300k. Okay? And then, plus yung present worth annuity. Yeah, ito. Wait lang. So, this is in perpetuity neto. So, ito siya. So, that will be plus 300k minus 30k divided by 1.18 raised to 15 minus 1. That will be equal to 324,604 to cover yung first 15 years. Then another one, and then another one until, di na okay yung makina. Here, I have an example of amortization, but essentially it's just ordinary annuity, pero we're talking about debt lang. It's just basically any method of repaying a debt, principal, interest included, through a series of equal payments at equal time interval. So it's just annuity lang and more specified lang on debt. Okay, so you should not be surprised if you have a problem na ganito. So I included this galing kay Santa Maria. I built yung table, but I just added lang kung paano. So ito yung future worth neto minus yung principal, so 5,000, and then you minus that. So yung payment dito, that will be your amortization. That will be your annuity basically. And then this one is your principal repaid at the end. So whatever your total neto. These are right over there.